Hello everyone, welcome to today's lecture on implementing energy efficient practices in buildings, challenges, strategies and success stories. My name is Vandana Chandrakar and I am excited to guide you through a topic that is critical to sustainable development and environmental management. This session will focus on the barriers we face in enhancing energy efficiency in buildings, the strategies to overcome these challenges and real world case studies that highlight successful implementation. In previous lecture, we have discussed about lessons learned from successful projects, in which we have covered key insight and best practices from successful projects, challenges faced and strategies for overcoming them, recommendations for future and energy efficient buildings projects. In this lecture, we will cover three main areas. First, the common challenges in implementing energy efficient practices. Second, strategies to overcome technical and financial and organizational barriers. Third, case studies illustrating successful solutions to these challenges. The goal of today's session is to equip you with the knowledge and tools needed to enhance energy efficiency in our own projects or organizations. Whether you are an architect, engineer, building manager or policy makers, understanding these concepts will help you contribute to more sustainable building practices. Let's delve into the first area, the technical challenges of implementing energy efficient practices. First challenge is technology limitations. One of the most significant technical challenges is the difficulty in integrating energy efficient technologies with existing building structures, particularly in older buildings. For example, retrofitting historic buildings with modern insulation or HVAC systems can be complex and costly due to structural constraints or preservation requirements. A study by the European Commission highlights that retrofitting older buildings to meet modern energy efficiency standards often requires specialized solutions that are not only expensive but also technically challenging to implement. Now, next challenge is lack of expertise. Another critical issue is the shortage of skilled professionals trained in energy efficient technology and practices. Many architects, engineers and builders are not only fully equipped with the latest knowledge and skills needed to design and implement energy efficient systems. The World Green Building Council has identified this gap in expertise as a significant barrier to achieving global energy efficient targets. Without adequate training and awareness, even the best technologies may be underutilized or improperly applied, leading to suboptimal outcomes. Next challenge is interoperability issues. The integration of energy efficient technologies with existing building management systems and other infrastructure can also present technical challenges. Ensuring compatibility and interoperability between different systems is essential for optimizing energy performance. This often requires specialized expertise and careful planning. Next challenge is emerging technologies and uncertainty. The rapid pace of technological advancement in the field of energy efficiency can create uncertainty and challenges in terms of adoption and implementation. New technologies may have unproven reliability or require specialized maintenance, which can introduce risk and increase costs. Next challenge is building codes and regulations. Outdated building codes and regulation can hinder the adoption of energy efficient technologies and practices. In some cases, existing regulations may not adequately address the latest energy efficiency standards, making it difficult for building owners to implement innovative solutions. Addressing these technical challenges requires a combination of factors including research and development. Continued investment in research and development is essential for developing innovative and practical energy efficient technologies that can be integrated into existing buildings. Another factor is education and training. Providing opportunities for professionals in the building industry to acquire the necessary knowledge and skills in energy efficiency is crucial. This can be achieved through training programs, workshops and certification. Next challenge is collaboration and partnerships. Collaboration between industry experts, researchers, policymakers and building owners can help identify and address technical challenges, develop best practices and facilitate the adoption of energy efficient solutions. Next is policy and regulatory framework. Updating building codes and regulations to reflect the latest energy efficiency standards and technologies can create a more favorable environment for investment in energy efficient projects. By addressing these technical challenges, we can pave the way for the widespread adoption of energy efficient practices and contribute to a more sustainable future. Let us talk about the financial challenges associated with the energy efficient practices. First challenge is high initial investment. One of the most cited barriers is the high upfront cost of energy efficient technologies. For instance, the installation of renewable energy systems like solar panels or energy efficient HVAC systems require substantial initial investment, which can be a deterrent for many buildings owners, especially in the commercial and residential sectors. The Energy Information Administration reports that while energy efficient systems can significantly reduce long term operational costs, the initial capital outlay remains a major hurdle for widespread adoption. Next financial challenge is long payback period. Even when the long term benefits are clear, the extended payback periods can be discourage investments. According to a study by McKinsey and Company, many energy efficiency projects have payback periods ranging from 5 to 10 years, which can be too long for some businesses to justify the investment, particularly in industries where short term returns are prioritized. Next is limited access to financing. Securing financing for energy efficient projects is another significant challenge, particularly for small and medium sized enterprises. The Global Environment Facility point out that SMEs often face difficulties in obtaining loans or financial incentives for energy efficient upgrades, primarily due to a lack of collateral or credit history. These financial barriers prevent many potentially beneficial projects from moving forward. To address these financial challenges, several strategies can be implemented. First strategies is government incentives. Government can play a crucial role in promoting energy efficiency by offering financial incentives such as tax credits, rebates and grants to encourage investment in energy efficient technologies. These incentives can help reduce the upfront cost for building owners and make energy efficient projects more financially attractive. Next incentive is energy efficiency financial programs. Financial institutions can develop specialized financing programs that cater to the specific needs of energy efficient projects. This could include low interest loans, energy performance contracts and green bonds. By providing lettered financing options, these programs can make it easier for businesses and individuals to invest in energy efficient upgrades. Now, third party financing. Third party financing models such as energy service companies can be a viable option for building owners who lack the capital or expertise to undertake energy efficient projects. Energy service companies can invest in and implement energy efficient upgrades and then recoup their investment through energy savings. By addressing the financial challenges associated with energy efficient practices, we can accelerate the adoption of sustainable and cost effective solutions that contribute to a more energy efficient future. Now, let us explore the organizational challenges that can impede the implementation of energy efficient practices. First challenge is resistance to change. One of the most pervasive organizational barrier is resistance to change. People are often hesitant to adopt new technologies or processes, especially when they are comfortable with existing methods. For example, a building manager might prefer to stick with conventional lighting systems rather than switch to LEDs, even though the latter are for more energy efficiency. The reluctance can stem from a variety of factors, including lack of knowledge, fear of the unknown, or perceived risk associated with new technologies. Now, regulatory and policy barriers. Inconsistent or unclear regulations can also hinder the adoption of energy efficient practices. The World Bank has noted that in some regions, building codes and energy regulations are either outdated or not enforced, making it difficult to implement modern energy efficient technologies. In other cases, regulations may conflict with energy efficiency goals, such as zoning laws that limit the installation of renewable energy systems. Next is communication and coordination issues. Effective collaboration between key stakeholders such as architects, engineers, contractors and building owners is crucial for the successful implementation of energy efficient practices. However, poor communications and lack of coordination can lead to delays, misunderstandings and ultimately suboptimal outcomes. A report by the American Institute of Architects highlights that integrated project delivery models where all parties are involved from the project inceptions can help overcome these barriers. Now that we have identified the challenges, let's discuss strategies to overcome them, starting with technical barriers. First technical barrier is training and capacity buildings. Addressing the lack of expertise require a focus on education and capacity buildings. Developing and promoting educational programs that train professionals in energy efficient technologies and practices is crucial. For example, certification programs for energy auditor, architects and engineers can provide the necessary skills and knowledge to implement energy efficient solutions effectively. The US Green Building Council USGBC offer leadership in energy and environment design certification, which is widely recognized and has helped to elevate the expertise of professionals in the field of sustainable building design. Moving on the financial barriers, here are some effective strategies to address them. First, financial incentives and subsidies. Government policies that provide financial incentives and subsidies can play a crucial role in making energy efficient technologies more affordable. For example, tax rebate for energy efficient appliances, grants for renewable energy installations or subsidies for upgrading insulation can significantly reduce the financial burden on building owners. According to the International Renewable Energy Agency, countries that have implemented robust incentive programs have seen substantial increases in the adoption of energy efficient technologies. Energy performance contracts are an innovative solution that can be overcome the challenges of high upfront cost. In an energy performance contracts, an energy service company funds the installation of energy efficient technologies and is paid back through the energy savings achieved over time. This model reduces the financial risk for building owners as the cost of the upgrades is directly linked to the saving generated. A report by the Lawrence Berkeley National Laboratory highlights the success of EPCs in reducing energy consumption in commercial buildings across the United States. Next is public-private partnership. Public-private partnerships can also be highly effective in financing and implementing energy efficient projects. These partnerships leverage the strength of both sectors, public funding and private sector efficiency, to achieve large scale improvements. For example, in the United Kingdom, the Green Investment Bank was established to fund energy efficiency projects, and it has successfully partnered with private companies to retrofit buildings and reduce energy consumption across the country. Finally, let's discuss a strategy to overcome organizational barriers, policy advocacy and reform. Advocacy for supportive policy and regulatory reforms is essential to overcoming organizational challenges. By engaging in policy advocacy, stakeholders can push for more stringent energy codes, updated building standards, and clearer regulations that support the adoption of energy efficient practices. The Environmental and Energy Study Institute has emphasized the importance of policy advocacy in creating an enabling environment for energy efficiency. For example, updating building codes to mandate higher energy performance standards can drive the adoption of energy efficient technologies. Next is stakeholder engagement and collaboration. Promoting collaboration and communication among all stakeholders is crucial. Integrated project delivery models, as mentioned earlier, involve all key parties from the project's inception, fostering better communication and collaborations. According to the American Institute of Architects, IPD not only improves project outcomes but also reduces cost and timelines. Regular workshops, meetings, and collaborative tools can further enhance stakeholder engagements. Next is creating a culture of energy efficiency. Fostering a culture of energy efficiency within organizations is vital. This involves educating employees about the benefits of energy efficiency and encouraging them to adopt energy saving practices. For instance, companies can implement energy awareness campaigns, provide training on energy management, and recognize employees who contribute to energy savings. The Carbon Trust has found that organizations that actively promote a culture of energy efficiency are more likely to achieve and sustain significant energy savings over time. Now, leadership commitment. Strong leadership commitment is essential for driving energy efficiency initiatives. Top level executives must clearly articulate the organization's energy efficiency goal and provide the necessary resources and support. By demonstrating their commitment, leaders can inspire employees to embrace energy saving practices. Next is performance metrics and tracking. Establishing clear performance matrices and tracking energy consumption can help organizations identify areas for improvement and measures the effectiveness of their energy efficiency efforts. Regular monitoring and reporting can also provide valuable insights for decision making and accountability. Continuous improvement. Energy efficiency is an ongoing process that requires continuous improvement. Organizations should regularly review their energy performance and identify opportunities for further optimizations. By adopting a mindset of continuous improvement, organizations can stay ahead of the curve and achieve their energy efficiency goals. By implementing these strategies, organizations can overcome organizational barriers and successfully adopt energy efficient practices. This will not only contribute to environmental sustainability but also lead to significant cost savings and improved operational efficiency. Let's delve deeper into the groundbreaking case study of the Bullitt Center in Seattle, often held as the greenest commercial building in the world. The Bullitt Center was designed with the ambitious goal of achieving net zero energy consumption. This means it generates as much energy as it consumes, primarily through its innovative design and the use of renewable energy technologies. The project was spearheaded by the Bullitt Foundation, a non-profit organization committed to environmental sustainability. Now, innovative design features of Bullitt Centers. The Bullitt Center incorporates a variety of innovative design features to maximize energy efficiency. These include first, passive solar design, utilizing natural sunlight for heating and lighting. Triple gauge windows providing superior insulation and reducing heat loss. Next is geothermal heating and cooling, harnessing the earth's natural heat for temperature control. Then rooftop rainwater harvesting, collecting and storing rainwater for irrigation and toilet flushing. Last is on-site composting, reducing waste and producing nutrient-rich compost for landscaping. Now, challenges and solutions. Despite its innovative design, the Bullitt Center faced several challenges during its construction and operation. This included first, high upfront costs. The initial investment in energy efficient technologies was substantial. Second is regulatory hurdles. Navigating local building codes and permitting processes can be time consuming and complex. Next is technical complexities. Implementing advanced energy system can present engineering and technical challenges. Then public perceptions, overcoming skepticism and gaining public acceptance for such a radical projects. To address these challenges, the Bullitt Center team employed a variety of strategies such as first, securing financial support, obtaining grants, loan and private investment to cover the initial cost. Next is collaborating with experts, working closely with architects, engineers and sustainability consultants. Then piloting new technologies, testing and refining innovative energy solutions. Last is engaging the community, educating the public about the benefits of sustainable building practices. Then successes and impact of these buildings. The Bullitt Center has achieved remarkable success in its quest for energy efficiency. It has not only met its net zero energy goals, but has also reduced water consumptions by 90% through rainwater harvesting and efficient fixtures, improved indoor air quality through the use of low VOC materials and natural ventilations, created a healthy and productive work environment. The building's sustainable features contribute to employee well-being, inspired others. The Bullitt Center has served as a model for sustainable building practices, influencing projects around the world. The Bullitt Centers offer valuable lessons for future sustainable building projects. By holistic design, consider energy efficiency from the outset, integrating it with other sustainability goals. Then collaboration and innovation, work with experts, embrace new technologies and seek innovative solutions. Community engagement, involve the public and address concerns to public supports. Long-term perspective, recognize the sustainable buildings is a long-term investment with lasting benefits. Next case study is Empire State Buildings retrofit, New York. Our second case study explored the iconic Empire State Building, a landmark that underwent a major energy efficiency retrofit in recent years. The Empire State Building, one of the world's most recognizable skyscrapers, faced increasing energy costs and environmental concerns. To address these issues, the building's owners embarked on a comprehensive retrofit projects with the goal of reducing energy consumption and carbon emission significantly. The retrofit involved a wide range of energy saving measures, including LED lighting, replacing traditional incandescent and fluorescent lighting with energy efficient LED fixtures. Then HVAC system upgrades, modernizing the building's heating, ventilations and air conditioning systems to improve energy efficiency. Window replacements, installing energy efficient windows to reduce heat loss and gain. Building automation, implementing advanced control systems to optimize energy usage. Renewable energy, exploring opportunities for on-site renewable energy generation such as solar panels. Challenges and solutions of this case study is, despite its iconic status, the Empire State Building faced several challenges during the retrofit processes. Preserving historic integrity, maintaining the building's architectural heritage while implementing modern energy efficient technologies. Second is financial constraints, balancing the cost of the retrofit with the potential energy savings. Then tenant disruption, minimizing disruption to tenants during construction and renovation works. Next is technical complexities, addressing the unique engineering challenges of retrofitting a towering skyscraper. To overcome these challenges, the Empire State Building's owners employed a variety of strategies such as phasing the retrofit, implementing upgrades gradually to minimize disruption, securing financing, obtaining loans and energy performance contracts to support the projects, collaborating with experts, working with experienced architects, engineer and energy consultant, prioritizing tenant comfort, communicating with tenants throughout the process and addressing their concerns. The Empire State Building retrofit was a resounding success, achieving significant energy saving and reducing its carbon footprint. The key outcomes include of this case study is reduced energy consumption, a substantial decrease in electricity and gas usage, lower operating costs, significant saving on energy bills, improved tenant comfort, enhanced indoor air quality and temperature control. Environmental benefits, a reduction in greenhouse gas emissions. Positive public image, the retrofit enhanced the building's reputation as a sustainable landmark. The Empire State Building's retrofit offers valuable lessons for other building owners. Prioritize energy efficiency, make energy efficiency a top priority in building operations. Consider holistic approaches, address energy efficiency through a combination of measures. Engage stakeholders, involve tenants, employees and the community in the process. Leverage technology, utilize advanced technologies to optimize energy usage. Measure and monitor, track energy performance to identify areas for improvement. Our last case study explores Bedjet, a pioneering eco-village located in London, England. Bedjet was developed with the aim of creating a sustainable low-carbon community. It was designed to minimize energy consumption, reduce waste and promote sustainable living practices. Sustainable design features of this building incorporate a range of sustainable design features including passive solar design, utilizing natural sunlight for heating and cooling, high performance insulation, minimizing heat loss and gain, renewable energy, installing solar panel and a biomass boiler for energy generation. Water efficiency, implementing rainwater harvesting and low flow fixtures. Waste reduction, encouraging recycling, composting and waste reduction initiatives. Community based approach for the success of this building. Bedjet's success is largely attributed to its community based approach. The development was designed to foster a sense of community and encourage residents to participate in sustainable living practices. The key aspects of the community based approach include shared spaces, providing common areas for residents to interact and socialize, community gardens, cultivating food and promoting self-sufficiency, car sharing programs, reducing reliance on private vehicles and promoting sustainable transportation, community workshops, offering educational programs on sustainability and environmental issues. Then challenges and solutions of these buildings. Despite its innovative design and community based approach, this building faced several challenges during its development and operation. First is affordability, ensuring that the housing units were affordable for a diverse range of residents, regulatory barriers, navigating planning regulations and obtaining necessary permits, community acceptance, gaining support from local residents and addressing concern about the development. Long-term sustainability, ensuring that Bedjet remains sustainable over the long term. To overcome these challenges, the Bedjet team employed strategies such as affordable housing, developing a mix of affordable and market rate housing units, community engagement, involving local residents in the planning and development processes, financially sustainability, implementing revenue generated initiatives such as community owned businesses, continuous improvement, monitoring and evaluating the development's performance and making necessary adjustment. Bedjet has achieved significant success in its goals of sustainable living. The key outcomes of this success are reducing energy consumption, significantly lower energy bills for residents, reduced carbon emissions, a significant reduction in greenhouse gas emissions, improved quality of life, a strong sense of community, increased well-being and reduced environmental impact. Inspiration for others. Bedjet has served as a model for sustainable communities around the world. In conclusion, BedJets offer valuable lessons for future sustainable developments. Community-centered approach, prioritize community involvement and engagement, holistic design, consider all aspects of sustainability from energy efficiency to social well-being. Long-term planning, develop a sustainable vision and plan for the project's future. Continuous improvement, monitor performance and make adjustment as needed. Innovative and adaptability, embrace new technologies and be open to change. Let's recap what we have covered today. We started by discussing the common challenges in implementing energy efficient practices, including technical, financial and organizational barriers. We then explored various strategies to overcome these challenges, such as training and research and development, financial incentives, stakeholder engagement and creating a culture of energy efficiency. Finally, we looked at 3 case studies that highlight successful solutions to these challenges: the Bullitt Center in Seattle, the Empire State Building retrofit in New York and BedJet in London. In the upcoming lecture, we will discuss implementing energy efficient practices, in which we will see practical steps for implementing energy efficient practices. Thank you and wish you a very happy learning. Thank you for your attention. I look forward to your questions and discussion on this fascinating topic.